Hi dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 364. In this lecture, we will try to understand learning rate, or there is another name for learning rate is step size. Learning rate or step size. In previous lecture, we saw in gradient descent xi equal to xi minus 1 minus r into df by dx at xi minus 1. What is this df by dx? This df by dx is slope. Slope at which point? At xi minus 1. In previous lecture, we said that r is constant. We said that r is kept constant. This is often called as the update equation for gradient descent. Now, r is often called as learning rate, also called as step size. Step size or learning rate are basically same. Now, let's take an example and see what problem it could create. If I keep my r constant, let's take an example of parabola. Suppose this is my y equal to f of x, which is equal to x square. Let me say this is my y equal to f of x, which is equal to x square. And what is my x? X is here. I have y, which is essentially f of x. Let's assume I reach a point where my xi equal to 0.5. Let it be. Let me assume I reach a point where my xi equal to 0.5. After some iterations, now my xi plus 1 equal to xi minus r into df by dx at xi, isn't it? What is this df by dx here? Df by dx is nothing but what is my f of x? F of x equal to x square. Df by dx means what is the d by dx of x power n? D by dx of x power n is n into x to the power of n minus 1. What is the differentiation of x square? 2 into x to the power of 2 minus 1. Therefore, your df by dx is essentially, I can say, 2x. Isn't it? Now let's assume we kept r constant. Let me assume r equal to 1. Let r equal to 1. What happens to my xi plus 1? What happened to my xi plus 1? My xi plus 1 will be, what is my xi here? Let me calculate xi plus 1. I am assuming xi is 0.1, isn't it? Therefore, xi plus 1 equal to xi means 0.5, r means 1, as we assume. Df by dx, df by dx, what is our df by dx is 2x, isn't it? Df by dx is 2x at xi. What is 2x at xi means 2 into, I can say, 0.5. Therefore, what will you get? 0.5 minus 2 into 1 into 2 into 0.5 means 1 by 2 means 1. 0.5 minus 1 means I will get minus 0.5. From here, let me say somewhere here you have minus 0.5. Isn't it? What's happening here? You are jumping, isn't it? What does it mean? So, what happens right now? This is, what is my x star? This is my x star. Optimum value of x, minimum value of y equal to f of x equal to x square. That this point origin is my x star. If my xi is here, my xi plus 1, where is my xi plus 1? Xi plus 1 is minus 0.5. I have learning rate, which is r, because of some slope that I have here. My xi plus 1 went to the other side. Xi is 0.5 and your xi plus 1 went to the other side, which is minus 0.5. What happened here? I went from 0.5 to, I went from where? From 0.5 to minus 0.5. But remember, we should actually go closer to x star. Our optimal solution is x star. You have to reach to the x star, our minimum solution, but we are jumping over this particular optimal solution. We jumped to the other side, isn't it? We jumped to the, yes, just see, we simply jumped to the other side, isn't it? Like this, we simply jumped over x star, isn't it? We should actually go closer to x star. We jumped to the other side. What happened here? We simply jumped over x star. When I am going from xi to xi plus 1, we jumped over x star. Now there is one more problem. What happened to xi plus 2? Just try to calculate xi plus 2. How can I calculate xi plus 2? Your xi plus 2 is equal to xi plus 1. What is my xi plus 1? Minus 0.5 minus, formula is r means 1 into df by dx is 2x. Therefore 2 into, what will you get? Minus 0.5 you will get. Just if you simplify this one, again what will you get? You will get your xi plus 2 will be 0.5. Therefore, if from xi plus 1 to, you will go to xi plus 2, isn't it? Just see, just check this particular calculation. Just I calculated here. Just see what's happened. Xi plus 2 is equal to 0.5. Therefore, you are jumping from xi plus 1 to your xi plus 2 like this, 0.5. Isn't it? My xi plus 2 is again 0.5. My xi plus 3, just calculate xi plus 3, again you will get minus 0.5. What does it mean? Basically, it is oscillating. What's happening here? It is oscillating. Just see, it is what is happening here. I am basically oscillating. I am oscillating between x equal to 0.5 and x equal to minus 0.5, isn't it? Why is this happening? Because my r has been kept constant at value of 1. If we write code simply, it oscillates between minus 0.5 and plus 0.5 and will never converge to x star, never move or converge, or never eventually move to x star, which is a problem. And what is the remedy to this problem? We have to find some remedy for this particular problem. What is this remedy? What is the remedy for oscillation? Remedy is you change r with each iteration. You somehow change your learning rate or step size with each iteration. One simple technique, of course, there are many ways. There are many ways to do it. One technique is to reduce r with each iteration. When you reduce r, what happens? First time you probably jump to the other side, isn't it? When you reduce r with each iteration, what happens? First time it may jump here, you probably jump to the other side, but since you are reducing r, you will not make full jump. Since you are reducing r, you will not make full jump. So somewhere you will jump here, isn't it? You will not make full jump. Come somewhere closer to this x star, isn't it? Somewhere closer to x star, because your r itself changed. R is basically becomes function of your iteration number. This problem occurs more and more as you are coming closer and closer to x star. We don't want this oscillation problem going back and forth. So what do you do to avoid this oscillation problem? You basically make your learning rate, we reduce it in each iteration. So you could say something like this. You can create r equal to some function of I, r equal to h of I, where I is the iteration such that as I increases, r should reduce, isn't it? In the literature, there are well-studied functions, but if you ensure that as the iteration number increases, if r reduces, eventually we will converge to the right solution, which is extremely important with learning rate or step size. When we learn deep learning, we will learn multiple techniques on how to modify r more effectively and efficiently. There are some modifications for simple gradient descent which works brilliantly well even for extremely large optimization problems. For now, the simple idea that R needs to change in each iteration is a good enough idea for most of the standard machine learning algorithms that we will learn. For deep learning, we will learn some interesting optimization on how to change R efficiently for effective converge to the global minima. Just go through this lecture. In my next lecture, I will discuss about gradient descent for linear regression. Thank you very much.